Welcome to this session. In this session, we are going to discuss about the second method of evaluating an inverse of a matrix from elementary matrices. And this method is also called the Gauss-Jordan method. So there's an appetizer to evaluate the inverse of A, given that A is a 2x2 matrices of elements 2, 1, 3, 2. But before we solve the problem, let's discuss the steps that you need to follow when you're using this method to find an inverse. So if A is reduced, remember A is a square matrix, is reduced to an identity matrix I by elementary operations, or transformations, then P times A is equals to the identity where P is a product Pn minus 1 up to P to P1. These are simply define the elementary. So P is the elementary matrix. So therefore, if you apply A inverse on both sides, we'll have P. If you post multiply both sides by A inverse, so we'll have P A inverse equals to I A inverse. A inverse is identity, and identity times A inverse is just A inverse. So which implies that the inverse of the matrix A is the same as P times an identity matrix I. Or similarly is to say that A inverse is the same as the matrix P, where P is the elementary matrix. So now the question will be, how do you find this P? To find P, these are the steps. So working rule. So write the matrix A as an identity matrix times A, and then to perform elementary row operations or transformations on A of the left side and on I of the right side, so that A is reduced to I, and I is reduced, to P, getting I is equals to P times A. Then P is the inverse of the matrix A. Now let's illustrate that in the problem at hand. So we have the matrix A given by 2, 1, 3, 2. Now this is how we write it. So solution for this, you write A and then you can separate by a line or a dotted line. Where I is the identity matrix, A is the square matrix, and this identity matrix is dependent on the size of A. So if A is of 2 by 2, then it will be 2 by 2. If A is 3 by 3, this will be 3 by 3. A is 4 by 4, this will also be 4 by 4. So this implies we'll have the matrix 2, 1, 3, 2, separate by a line. Identity matrix of order 2 is 1, 0, 0, 1. So the work is to use row operation so that this part is changed to an identity matrix, while this part is the one that will give us the P matrix, which will be the same as the A inverse. And the normal of row operations that we specified earlier are the same state that you're going to use. So the first thing, remember, for this to be an identity matrix, then we need it to have this structure. And you see, for us to have this structure, the first thing is that this element must be 1. So we'll say we correct row 1 by making that row 1, you multiply by a half, so that this will be a half, it will be 1. And let's keep row 2 to be just row 2. So therefore, that will change the matrix to 1. This will be a half, 0, 3, 2, 0, 1. And when you are carrying out these row operations, it's advised that unless otherwise specified, or if unless it is impossible to write the numbers as fractions, try as much as possible to ensure that all your values are in fraction form so that you don't introduce errors in the calculation. Just use the values in fraction form to avoid losing the accuracy in the calculation. Now, this is 1 as it should be. So what we do is say row 1 to be row 1. Now row 2, we expect this point to be 0. So we'll say row 2 plus now negative 3 row 1. So that we'll have the matrix. So this will be 1, a half, 0. Now here, I'll have 0. Now 2 plus minus 3 times a half. That gives me a half. And then 0 plus minus 3 times a half gives me minus 3 over 2. And then 1 plus minus 3 times 0 is just 1. Good. Now remember, at this point, I should know that it should have this structure of an identity matrix. So expect this position to be 1. So how do I make 1 here? I'll divide, or I'll multiply everything by 2 in this row so that I get this position to be 1. So I'll say my row 1 to be row 1, my row 2 to be twice row 2, so that I ensure that this position is 1. Now this will transform this matrix into 1, a half, 0, 0, 1. This will be -3, and this is 1. So that's what we get. Now, the only problem remaining, remember the structure of a 2 by 2 identity matrix. So this is agreeing with this part, this is agreeing, this also agreeing. So the only problem with this part, we need this one to be 0. So I'll say row 1. In fact, I can as well do it away with fractions on this one. Okay, so row 1, for me to have 0 here, I'll say I need to say row 1 plus negative a half row 2, so that a half plus minus a half is 0. And then row 2 will just be remain to be row 2 because it is in the required form. So row 2 remains to be row 2. So that will give me 1, because 1 plus minus a half times 0 is just 1. Now a half plus minus a half times 1, I get 0 now. And then a half plus minus a half times this element is -3. So I get 2. And then 0 plus minus a half times 1. I get negative a half. So this 0, the 1, the 2, I get negative a half. And then, so this position was, so 3, the first one we started with multiplying by a half. So a half, this a half 0, that's fine. 3, 2, 0, 1, that's okay. And then row 2, so we have 3 minus 3, 0, 2 minus 3 over 2 is a half. And then 0, this should be 0, and minus 3 over 2, that's fine. And then 1, that's okay. And here we have so row 1, negative a half times row 2. Okay, now so now this one, this is row 1. So twice row 2 will have 1 minus. This was supposed to be 2. You see now when you say new row 2, we are multiplying 2 by, so 2 by this one, 2 by this, so 2 by 1 should be 2. So this element should be 2, not 1. So that now when you say 0 plus negative a half times 2, that will give us negative 1. Yeah, so this will be negative 1. And this is 0, this is 1, this is negative 3, and this is 2. So therefore, because this is now an identity matrix I, so you take this as your P. So therefore, P, which is the same as A inverse, is given by 2 minus 1 minus 3, and then 2. So this is the inverse of that matrix, which you can confirm because these are 2 by 2 matrix. It's very easy to calculate to calculate the inverse. So this negative 1. Remember, we had 2, 1, 3, 2. In the normal case, we'll say determinant will be given by 2 by 2 minus 3 by 1. So 4 minus 3, which is 1. And then you say 1 over determinant. 4 minus 3 equals to 1. So this plus. And then change these elements, interchange the elements along the main diagonal, and change the signs here. Minus 3, minus 1. So it will be the same as 2 minus 1 minus 3, 2. And which is the same answer that you have obtained here. So give more examples in the next session. Thank you.